Hi everybody. I want to go over some practice with laws of logic. This is part of the review for the quiz we're going to have coming up. Do this page as well as possible, then watch the video and see if you agree with what I've written here. First I have to list the laws of logic. I'm going to give an example of each. Just the same kind of examples I showed you before. For the law of detachment, if P then Q, we know that P is true. Therefore, what conclusion could you draw? And I hope you recognize that we would draw the conclusion Q. That's just a statement of the law of detachment. I want to lay those laws out here before we're asked to use them on the bottom of the page. The law of syllogism. If P, then Q, and if Q, then R. Those were our premises. What conclusion could we draw? And it's called the law of syllogism. It would be that if P, then R. We'll call that the law of syllogism. You should be familiar with the disjunctive syllogism, but here's an instance of it. P or Q, it begins with a disjunction, and we deny one of the disjuncts. I could deny P, and that would lead me to a conclusion. That conclusion would have to be Q. It's either P or it's Q, but it's not P. It must therefore be Q. And the law of contrapositive, I hope you know it already, but here's what I would tell you about it. It goes with if P, then Q, a conditional. And you deny the conclusion of that conditional. We have not Q as a premise. And therefore, what conclusion could you draw? That conclusion would be not P. That's the law of contrapositive. And there are two instances of De Morgan's law. I hope that you know them both, but here they are again. The negation of P and Q. When I bring this negation through these parentheses to get a logically equivalent statement, that and statement becomes an or statement. It becomes not P or not Q. Had there been a negation outside of parentheses with a disjunction, and I bring that negation through the parentheses, that or statement becomes and that would become not P and not Q. And those are all fine and good arguments, but what we really care about is using them to work through and make conclusions. Here's a few that I've written. If Paul is not present, then Ralph will not be present either. Paul is not present in the class, and Ralph is present, or Susan is. I'm supposed to use P, R, and S and show that Susan is present. The first premise, Paul is not present. If Paul is not present, then Ralph will not be present either. That would be if not P, then not R. Paul is not present, therefore that would be not P. And I have a third premise, Ralph is present or Susan will be present. That should be R or S. So I can refer to these statements. I'm going to call the first one 1, and the second one 2, and the third one 3. And then consider what I can do together. And if we look at the first two statements, not P gives me not R, and we have not P, my conclusion for number 4 would be not R. That's the law of detachment. And I should make that note right there, law of detachment. I apply the law of detachment to statements 1 and 2. But let's look further then. Can I hook this statement 3 with this statement 4? It's R or it's S, but it's not R. My conclusion is, therefore, it must be S. How do I draw that conclusion? I have a disjunction and I deny one of the disjuncts. That's an example of a disjunctive syllogism. So I should say over here, disjunctive syllogism. And where did I apply the disjunctive syllogism? On statement 3 and 4. So I come to the conclusion that apparently Susan will be present. Therefore, Susan is present. So you see what we got to do is be able to use these laws, know these laws, be familiar with them, and order them and put them to work to solve an argument. Here comes another. If Abel works on the project, then Beth will participate. I see I'm going to use A, B, and C. For that one, that would be, if Abel works on the project, then Beth will participate. Looks like it ought to be that statement. That'll be premise number 1. Setting up the second premise, if Beth participates, then Carol will join the team. I'm using A and B and C. I think that must be if Beth participates, then Carol will join the team. Must be if B, then C. But I'm told here in my third premise, Carol does not join the team. That would be not C. So these are my premises, and I'm supposed to come up with a conclusion. I'm supposed to show that Abel did not work on the project. I'll work that through here. There's a couple of ways you could approach this, I'm sure, but here's one that works for me. I could put the first two statements together. If A, then B, and if B, then C. I conclude on statement 4, if A, then C. And that's the law of syllogism. Go look at the law of syllogism if that doesn't make sense. That's just about what happened right there. I use the law of syllogism on statements 1 and 2. And then I think, it's A, if A, then C, but we have the denial of C. If we have the denial of C, that leads me to the denial of A. So, I can come to this conclusion. What law did I just use? I want to have a conditional, and the denial of the conclusion, it leads me to the denial of the hypothesis. That's the law of contrapositive. Look at the law of contrapositive and see if you agree. And where did I apply the law of contrapositive? On statement 3 and 4. Look at statement 3 and 4. If A, then C, but we have the denial of C, doesn't that lead me to the denial of A? And that argument is finished. I have arrived where I wanted to arrive. I wanted to arrive saying Abel did not work on the project. That's my conclusion, so I'll say, therefore, Abel did not work on the project. We're keeping it simple. These could get much more interesting. Work on the project. Let's look at another. If Abel goes to school, then Beth will go to school. If Beth goes to school, then Carol will not go to school. Abel will go to school. Carol or Diane will go to school. I'm supposed to use A, B, and C, and D, and show that Diane will go to school. Let's do that now. The first premise, if Abel goes to school, then Beth will go to school, ought to be if A, then B. We're just going to use the variables A, B, C, and D. That'll be my first premise. And the second premise, if Beth goes to school, then Carol will not go to school. So my second premise would be if B, then not C. Carol's not going to school. Third premise, Abel does go to school. And the fourth premise, Carol or Diane will go to school. I guess that'll be C or D. And those are my premises. And I'm going to use these laws of logic, and I should come to the conclusion that show that Diane will not go to school. Sorting through all these ideas. It appears to me that the first two could be put together using the law of syllogism. I'll call that statement 5. You're familiar with the law of syllogism? Look at it now if you aren't. If A gives me B and B gives me not C, truth is A gives me not C. We'll call that the law of syllogism. Looking for the sixth step now. A gives me not C, and we have A. Therefore, we have not C. To arrive at that, I have a conditional, and the hypothesis is known to be true. Therefore, the conclusion must be true. That is the law of detachment. Let me be more clear here. The law of syllogism, I put that together with statements 1 and 2. Where did I use the law of detachment? I was looking at if A, then not C. If we have A, therefore we have not C. That was statement 5 and 3. If you look at statement 5 and statement 3, if A, then not C, we have A, therefore we have not C. Yep, that's the law of detachment. And then I couple statement 6 with statement 4. It's either C or it's D, but it is not C. What conclusion would you draw? It must be D. That's a disjunctive syllogism. You see that it's important for you to be familiar with these arguments at the top of the page. Disjunctive syllogism. Where did you use the disjunctive syllogism, mister? I used it with statement 4 and 6. C or D, but not C. Yep, that led me to this conclusion. So disjunctive syllogism on 4 and 6. So my conclusion is, therefore, D, and D tells me that Diane will go to school. Therefore, Diane goes to school. And that's pretty good. Let me just show you a couple of things that you might find to be interesting. And I'm not sure that we'll use them in class, but I think that they're really pretty cool laws. Check this out. If P, then Q. And if R, then S. That's my first premise. And then I tell you I have P or I have R. You think there'd be a conclusion you can draw? This is not a homework question. It's just a little extra for experts. And I think that some of you could probably draw a conclusion here. This happens to be called a constructive dilemma. There's one that's also called a destructive dilemma. I'm just going to set you up. Maybe you can think it through yourself. It would be if P gives me Q, and if R gives me S, and we have either the denial of Q or the denial of S. Could you draw a conclusion? And somewhere along the line I should tell you what these answers are, but I just want you to have a chance to think them through. And once you think them through, let's talk